Hi, welcome. In this video, we will learn quick sort asked by companies like Amazon, Microsoft, Apple, and Facebook. Quick sort. So far we have understood our selection sort, right? And then we have understood bubble sort, okay? And we have understood merge sort, right? So merge sort, the time complexity was big of n log n, right? And now we have this quick sort. Quicksort is also the time complexity of n log n. So why we are studying one more new algorithm when we have already one with same time complexity? The first reason is the space complexity of merge sort. We understood what was it? That was big O of n, right? But here in quicksort, the time space complexity is big O of 1. That is, it is an in place algorithm, right? We don't require any space. And also, you should be clear with the how to create sorting algorithms from scratch, right? You should know at least these four, right? You can add one more insertion sort. And although for the interview perspective, sorting algorithms is very, very important, right? So you should learn about all the different variations of sorting algorithms, what types of questions can be asked around sorting algorithms. Okay. So let's understand the quick sort. Okay. Basically, what we will try to understand everything, what is the intuition behind to use quicksort, and what is the code, dry run of it. Okay, so let's understand it. So here you can see we have this complete array, right, of different elements, right? And now we need to sort it. So what we will do? So here in quicksort, right, if I write down these steps, okay, in quicksort we first identify the pivot element, okay, or you can say we will consider the pivot element. So now, which element can be the pivot element? Okay, so the answer is any element can be your pivot element. Okay, any element from the array. It can be your random element, right? It can be your leftmost element. It can be your rightmost element. Okay, and it can be your median. Any element, right? Any element you can take. Why I'm saying any element? So basically, I will tell you in future basically how it works so that you get it, why it is not important to take some particular pivot element. You can take any pivot element. Okay, so let's suppose I will go with the left one, right, leftmost pivot element. So I will take this as my pivot element. Okay, so I can say like pivot equals to AR of 0, right? Or I will take AR of low. Now, what is this low? I will tell you. So basically, remember in merge sort, right? We break down the arrays into two parts, but that is hypothetical. And how hypothetically? When we consider their parameters, right? So their parameters from low to high. So here also I will use the same, right? This will be my low, low pointer, and this will be my high pointer. So basically, low to high will tell, right, like what is my length of the array, right? If my low is at 0, high is at the last most point, that is my complete array. If my high is at here, that means half of this array. Okay, so what I will do, I will first consider that this pivot element, and my goal is to, I want to find a position for this pivot element. What will be the correct position of this pivot element? Okay, so if I consider the correct position of my pivot element, it will be here, right, around 4, right? So if I say my pivot element correct position will be here, but how I will place this pivot element here? Okay. So the intuition behind this is I will start from my low pointer. I will start from high pointer. And if there are any elements, if there are any elements that are lesser than 5, I will put on the left side. Okay, and if there are any elements that are greater than 5, what I will do, I will try to put them on the right side. So whatever the space will left will always be the correct position of my pivot element. Okay, this is the intuition behind it. And let's see, let's try to solve it. So what I will do, I will start with low, I will start with high. Okay, and my low goal is to find out the lesser elements. Okay, the lesser element should be on the left side. High goal is the greater element should be on the right side. Let me note it down. Okay, so the second step will be lesser elements, then pivot, would be on left side. Okay, and greater elements, then pivot would be on the right side. Okay, now lesser elements. Okay, so I will check with 5. So is 5 is lesser than or equal to, let's put low to the lesser than equal. So that means it's okay, it's equal to it. So what I will do, I will simply move ahead, right? If it is even equal, let's take the equal, because there are some elements that are also equal. So let's put equal cases to low, right? That should come under the lesser elements category. Okay, left side. What I will do, I will move my low pointer to here. Okay, so not low pointer, low will be basically tell my array position only. Let's consider new parameters. Basically, let's take L, left pointer and right pointer. Okay, so left element, okay, left element, that is 5, that is equals to my pivot element. Okay, so what I will do, that is on the correct position, I will simply move ahead. Now 9 is greater than 5, it should not be here, so I will stop it here. Okay, now right is at 3, which is lesser than 5, it should not be here, right? It should be on the right side. So what I will do, now what I will do, I will swap them, right? So I will simply swap them. So if I swap them, right, my 3 will come here, my 9 will come here, and my left pointer will move, my right pointer will. Okay, so 1 is lesser, yes it is lesser, I will simply move. It is greater, yes it is greater, I will simply move. Okay, so if I'm moving, I will simply put the elements here as well. That means I'm not touching it. Okay, now left is pointing to 6, which is greater than 5, it should not, it should be at the right side. R is pointing to 4, which is lesser than 5, it should be on the left side. So what I will do, I will again swap them. So 4 will come here, 6 will come here, and my left pointer will move, and my right pointer will. Okay, now left is pointing to 7, which is greater than 5, so it should be on the right side, and R is pointing to 2, which is lesser, so it should be on the right side, like left side here. So what I will do, I will again swap them, right? So if I swap them, 2 will be here, 7 will be here, and my right pointer will move forward, and my left pointer will move forward. Okay, and it will be here. Let's make it from here, it will be. Now you can see my R is greater than L. Okay, so that is my stopping condition. I will stop it here. Okay, my right pointer is greater than L. So what I will do, okay, whatever my position of the right, that will be my partition, right? That will be my partition point, and I will say that is my pivot point. Okay, here should be my pivot point whenever it is stopped. Okay, so what I will do, I will swap with my 2 with my pivot element. So what I will do, I will simply swap them, and my 5 will come here. Okay, and 2 will come here. Now if you look closely, right, you can see all the elements that are lesser from 5 are on the left side, all the elements that are greater than 5 are on the right side. And now can I say that my 5 is at the correct position? Yes, my 5 is at the correct position, this position is correct. So that's how I am able to basically place my pivot element at the correct position. Now what I will do, now I have two parts, right? One this part and one this part. So can I say my, this is basically the partition element now, right? Partition element. Okay, so what I will do, I will now sort this array and sort this array, basically again doing the same. So what I will do, I will take this as a pivot element and then I will place it. Okay, so pivot element again find its correct position. Similarly here pivot element find its correct position. So basically I will do this with all the elements, and all the elements will find the correct position and the array will be sorted. Okay, so that's why I said, if even if you are taking any random element and if you are placing it at the correct position, all the elements will be sorted and you will get the correct order. Okay, so now let's solve our left part. Okay, so again what I will do, I will simply take this part and I will sort it this part. So if I am, let me take it here, and again I will consider this as my pivot element. Okay, and my low pointer will be here, my high pointer will be here. So now you can see my low pointer is already pointing to the same, but my high pointer is partition -1. So partition index -1, okay, is my high pointer. So high pointer is changed down. Okay, now what I will do, I will do the exact same, right? I will find out the left elements and the right elements. So let me quickly create a space for it. So now, okay, I will do the save. So again, I will take one left pointer and one right pointer. Okay, so left is at low and right is at high. I will check is 2 is basically 2, left pointer is equals to 2, my pivot. I will simply move my left pointer. Okay, is the right 4. Okay, is at the correct place, right? 4 should be greater than 2 and it is at the right place. So my right pointer will also. Now 3, right? I have 3, left pointer is pointing to 3. Okay, here should be some some low element, right? Lesser than 2, right? So my left pointer is pointing to greater and 1 is like right pointer is pointing to the lesser. So what I will do, I will swap them, right? Basically here I want lesser elements on the left side and greater elements on the right side. So what I will do, I will swap them. So if I swap them here, right, 1 will be here and 3 will be, and let's suppose 4 was here only and 2 was here. So now after this, what it will happen, right? Your right pointer will be here, your left pointer will be here. Okay, and once, can I say my right pointer crosses the left pointer? Yes, so I will stop here. What I will do, I will swap my right pointer with the pivot element. So I will swap them, right, 2 and 1, right? So if I swap them, it will be 1 and this will be my 2. So here now my partition element is 2, right? You can see on the left side we have lesser elements, on the right side we have greater elements. Okay, now what I will do, I will swap again. I will simply sort the left part, right? So if I sort the left part, now I have single element. So single element is itself sorted. No need to sort it again. Okay, now what I will do, I will sort the right elements. Okay, so now when I'm sorting the right elements, you can see a low pointer will be here. So low pointer is partition plus 1 now. Okay, and high is pointing to the same. Again, I will take left pointer and right pointer and here this will be my pivot element. 3 will be my pivot element. Okay, so L is pointing to 3, which is lesser than equals to 3. So my L pointer will move to the right side. Okay, and R is pointing to 4, which is greater than 3. That is also at the correct position. So what I will do, even if I am swapping here, so right, it will be here. So see, 4 is at the correct position, right? It should be greater than 3. It is here, right? So my right pointer will move ahead, right? Because it will find there is, right, there should be some greater element. So it will check 4 and it will move ahead. And now here you can see R crosses L. Okay, when R crosses L, I will stop it and I will swap R with my pivot element. So I will, if I swap R with pivot element 3, it will be same, right? So now it will be same and 3 will be here. So can I say my 3 is at the correct position, right? Now what I will do, I will sort the only right part and we in the right part we have only 4, that is itself sorted. Okay, so this is 4 sorted, 3 I have done sorted, 1 is sorted, 2 is sorted. Can I say this complete left part is sorted now, right? So if left part is sorted, what I will do, I will put it here and this complete left part is sorted. So it will be now 1, 2, 3, 4, right? I will do the same with the right part. We'll do the same with the right part, 7, 6, 8, 9. Again, let's do. Okay, and let me be this stuff. I will take this pivot element and you can see partition plus 1 is now low and this is at high. Okay, so what I will do, I will again take my left pointer here, my right pointer here, right? So left pointer is pointing to 7, which is lesser than equals to 7. I will move ahead, right? Now right pointing is pointing to 9, which is greater than 7. So I will simply move ahead. Okay, so left pointer is pointing to 6, which is lesser than 7. So what I will do, I will simply move ahead. Right pointer is pointing to 8, which is greater than 7. So I will move ahead and here right crosses L, right is greater than L. So what I will do, again I will swap this right, okay, with my pivot element. So if I swap them, the array will be here. You can see, right, it will 7 will come to here and let goes yellow. 7 will come to here and 6 will come to here and 8 and 9 will come to here. Okay, now on the left you can see all the elements are lesser, on the right all the elements are greater. Even if I further divide it into 6, so I will have only 6. Okay, that is itself sorted. even if I do 8 and 9, the same thing will happen that happened with 3 and 4, right? That will happen and we will come with this sorted. And if I place this here now, right, it will be, we have 6, then 7, then 8, then 9. Okay, you can see all the, like the complete array is now sorted. So this is the intuition, right? What we basically do, right? Now you can see from the top of it, I have choose this pivot element. I have placed this in the correct position. Then my work is divided into two parts, right? Left part and right part. I take the left part. I have choose this as a pivot element. I have put in the correct order. Then on the single element, this was the pivot element. This is the single element that is sorted. So here, so this becomes sorted right here. When we have 3 and 4, right? This was my pivot element. My pivot element is at the correct position. I simply put 3 here. So this was also sorted. 4 was single element. This was also sorted. All the elements were sorted. Similarly here, when I got this part, this 7 become my pivot element. I put in the correct position, right? Then I have 6 and 8, 9. 6 is the single element already sorted. If I do 8 and 9, right? So here you can take 8 and 9. This is pointing to left. This is pointing to right. So left is basically is equals to, so this is pivot, left 8 is lesser than equals to 8, L will move ahead, right 9 which is greater than 8, so it will move ahead. If you swap with 8 to 8, it will be here, right? So this is also sorted, right? Now 9 is a single element, this is also sorted, 6 is single element sorted. Okay, now all the elements are sorted, I have put, so here you can see the complete array is sorted. So the only trick is you are going to take a pivot element and lesser elements on the left side, greater elements on the right side. That's the only thing. That's the only trick. Okay. So I hope you got the complete intuition how this is working and why this is a really effective way, right? Now you might ask that we are like, are we breaking it down the arrays into two parts? Then again here in the two parts, no, right? What will be my low and high pointer basically represents the array. So here low is at 0, high is at 8, so it is representing the complete array. Now here low is at 0, but high is at which index? 3 index. So I have an array till 0 to 3. So I will basically do all the operations till 0 to 3, right? Then here even if I am taking this part, low and high both are equal, right? So what I will do, that's a single element, I will simply return it. Okay, so remember this will be our base condition. And now you can see I am doing the same thing. Whatever the thing I have done, I am doing on the left side. Okay, I am doing on the right side, right? So what we can do, we can use here recursion. We can use here recursion because we are doing the same exact same thing again and again, again and again. Okay, so now let's come to talk about basically what will be the code, how we will code it out, right? I basically say that my 5 element will get the correct position. I showed it also. Basically, if we are putting lesser elements on the left side, greater elements on the right side, the position that will left will be the correct position of the your pivot element. Okay, so this is how basically we do. Okay, now let's see what will the code of it. So let me write the code of it. I will simply write quick sort. Okay. In quick sort, what are the things that I am going to take? I have an array, right? Then I have low and high. Basically, low and high will represents my array length. Okay, and I will simply, I have this function. Now you can see here, okay, whenever my low and high equal, right? You can see when I divide this, my low pointer will point to the same and high pointer will point to same. When I divide this one, my low and high will point to the same. That means I should stop it here. I should stop here. So I will simply stop whenever my low, okay, whenever my low is equals to high, okay, or you can see low is getting greater than or equals to high, okay, greater for the worst case, but even like it's not required, low is equals to high, I will simply return it. Okay, so what I will do, what will be my first thing, that I need to find the partition. Okay, I need to find the partition index. I want, because to divide it, I first want to know where is my 5, so that I can divide my array, so that I can divide my array in the low and higher. So what I will do, I will first find the partition. Okay, how I will get partition index? So you can simply say your index, okay, partition index will be your partition function. You will pass the array and you will pass your low pointer and your high pointer. Okay, this will give you the index. This will give you the index. Now what you will do, you have the index. you will do the same thing, exact same thing with the left part and right part. How? So you will say ARR of low with index -1. Now your high will change to index -1. Okay. And here you will say quick sort array with low, not low. Here it will be from index +1, index +1 to high. Okay, and that's it. This is your complete quick sort. This is your complete quick sort. Okay, this will be simple code. Right now, nothing needs to be added. The only things that needs to be added, you need to find how we are doing the partition, right? How we are doing the partition, what is the code of the partition. So let's try to understand what is the code of the partition. Okay, and that is also very simple. Okay, so let me write down here. I will create my function partition. Okay, and let's understand this with the dry run, or let's first write the code, then we will do a quick dry run to understand it. So we have one partition, okay, function partition. I have one array and I have low pointer and high pointer. Okay, now as you can understand here that I will use one left pointer that is pointing to low. Okay, I will use my right pointer that is pointing to high. Okay, now what I will do, I will run this till my left pointer is lesser than right. So while my left pointer is less than right, I will run a loop. Okay, what will be my loop? So basically in the loop there were three conditions, and let me put this a bit here. So what I will do, I will simply say while, okay, left pointer is less than right, it's less than high. Okay, left pointer is less than high, and if I am getting any array left, okay, any array left that is lesser than or equals to my pivot. So ARR of pivot. Okay, what I will do, I will simply say this ARR of pivot. Okay, if this is true, I will simply say what I will do, I will simply say left plus plus. That's it. Okay, nothing needs to be added. And I have missed here. I need to add my pivot. My pivot will also be there, and I am considering my pivot will always be my low edge. Okay. Now the next condition will be while, okay, while right is greater than low. Okay, so basically my right is greater than low, and if my array of right, okay, is greater than, because I have put it equal to here, so greater than my pivot element. Okay, what I will do, I will simply do right minus minus. Now I will come to here only when my left is pointing to greater element, and I will come here whenever my right pointer is pointing to some lesser element. So in that case, I will check if my left pointer is lesser than my right pointer. What I will do, I will simply swap them, right? So I will swap between the left and right. Why am I able to print right? The right, yes. This will be my if under if condition. Once this if condition is done, this while condition is done, right? Suppose this is ended here, okay. When I will come out from my while condition, then what I will do, I will swap. What I will swap? I will swap my right with my pivot. Okay, and that's it. And I will return right. Basically, I will return right, and that will be basically my pivot, my partition index, right? So here basically I am swapping the elements and I am returning this index is my partition index. Remember, this index is going to your partition index. Okay. So now let's quickly understand it, how this is working. Let's create these. Let's take an example of the same array. So I will take the same example. So now let's understand this whole code by taking this example. Okay, so now we will do the dry run. Let's see, left is pointing to low. So when I started array, this is my low. Okay, this is my high. Okay, so low is pointing to here, high is pointing to here, and let me write the indexes. Okay, and we have, right, so I will take one left pointer that is at low, right? So here suppose my left pointer, right pointer is at high. So here suppose my right pointer. Okay, and my pivot is at low, so my pivot is at here. Okay, while left is less than right, yes, L pointer is less than right R pointer. So what I will do, I will say if left is less than high, yes, left is less than high, and array of left is lesser than equals to pivot, yes, it is equal to pivot, do left plus plus. So I will simply do left plus plus. Okay, now what I will do, I will check again, right? Because I am in the while loop, this is the while loop. So let's run it completely. Is here, is left is less than high? Yes, left is less than high. Is array of left is lesser than equals to pivot? So no, 9 is not lesser than equals to pivot. Okay, so I will stop here. My left pointer will stop here. I will execute this while loop. Now let's execute this while loop. Is the right is greater than low? Yes, right is greater than low. This is my low. And array of right is greater than array of pivot. So is 3 is greater than 5? No, it's not. So I won't do right minus minus. I won't do right minus minus. My right pointer will also be here. And I will come to this condition, is if left is less than right? Yes, it is. So simply swap left and right. So what I will do, I will swap them left and right. So if I swap them here, left and right, let's use the same array, right? So that I guess we will get it clear. So let me just put it here and increase its size. So what I will do, I will swap them. So I will swap 9 and 3. So here we will get 3 and here we will get 9. Once this is done, right, again I have this while loop, right? Is left is less than high? Yes, left is less than high. And array of left is less than equals to array of pivot? Yes, now it is indicating to less than, now 3 is less than 5. So what I will do, I will do L plus plus, my L pointer will here. Now again I will check, is 1 is less than 5? Yes, it is. So left plus plus, again do left plus plus. Now here array of left is not lesser than equals to pivot. So I will stop here, right? And now let's come here. Is right is greater than low? Yes, right is greater than low. And array of right is greater than array of pivot? Yes, 9 is greater than 5. So do right minus minus, my right pointer will here, right? Again 8 is also greater than 5. Do right minus minus, my right pointer will here. Now 4 is lesser than 5, right? So this condition will break and I will come here. If left is less than right, yes, left is less than right, swap them. So I will swap 6 and 4, right? So it will be 4 here, 6 here. Again I will, right, come here. You can see. So you can see here, right, I am basically running a while loop. This is inside a while loop, right? I will come only when here, when this while loop will break, right? Still left pointer is less than right. So what I will do, I will do the same, right? I will do the same and I will say, is left is less than high? Yes, it is less than high. Okay, so array of left is less than equals to a pivot. Yes, 4 is less than equals to 5. So what I will do, I will simply do left plus plus, my left pointer will be here. Similarly, right now 7 is greater than 5. So I will stop. Right is greater than low. Yes, 6 is greater than 5. So simply do right minus minus, my right will be here. Okay, now again right is 2 is greater than 5. No, it's not. So my right pointer will here, left pointer is here. And is your left is less than right? Yes, it is. Swap them. So I will swap them. 2 will come here and 7 will come here. 2 will come here and 7 will come here. Again I will check, right, because I am in this condition, right? Remember, I am in this condition. While left is less than right? Yes, it is. Okay, again check, is array of left is less than equals to pivot? Yes, 2 is less than equals to 5. Move your left pointer, right? Is 7 is greater than 5? So 7 is now greater than 5. So I will stop. Again, array of right, is array of right is greater than array of pivot? 7 is greater than 5. Yes, move your right pointer. Okay, now you can see, is array of right is greater than array of pivot? No, 2 is not greater than. So I will stop here and I will check, is left is less than right? No, that is also fail. And I will check then while condition, is left is less than right? No, that is also failing. So now I will come to this condition, swap right and pivot. So now I will swap the right and my pivot element, and if I swap 2 and 5, it will be 5 will be here, 2 will be here. So 2 will here, 5 will here. Okay. And I will return right, and I will return this index. I will return this index, right? So basically now what I will do, now I will sort this, right? And I will sort the left part. Okay. So this is how it will work, right? So now you are clear with how your partition function will work, how it basically return the index. Now we are good to do the dry run of this quick sort. Okay. So let me decrease its size, and let's quickly do a bit of dry run of this so that we can understand it more clearly. So again, I will take the same example, and let me create the array. So now let's do the dry run of this. So I will call my quick sort function first. So I will call my quick sort function with low and high. So low is pointing to 0 and high is pointing to 8, right? So I can say I will call quick sort function 0, 8, right? So this is my low and this is my high. Okay. So is low is less greater than equals to high? No. So I will find out the index of my partition low and high. So what will be the index? We know, right? So this is my basically in the partition, this will become my pivot element. Remember, in partition, always your pivot element is low here. In my code, right, you can take right as well. So pivot, right, you will find the correct position and that will be here. So you will, your index will be 4. Okay, so I can say my index, okay, I can use yellow color. I can say index will be 4. Okay. Now, so can I say my after this complete partition function, my 5 will find out the correct position, right? So my 5 will find out the correct position, and all the elements will come that are lesser will come to on the left side. So let me quickly create it. Okay, all the elements that come are lesser will come to left side. So it will come here. We have, right, 3 will come, then 2 will come here, I guess, then 4 will come, and 1 will come here. All right, and here we will have the greater elements. So we can say we will like the elements were, I guess, 9 was here, then 6, 7, 8. Somehow these were the elements. Okay, after first partition, 2, 3, 1, 4, and 7, 6, 8. So I can simply say 2, 3, 1, 4, and 7, 6, 8, 9. So let me say 7, 6, 8, 9. So this is after your this function is done. Okay. So basically you called partition function. Okay, you called partition function with value of low and high. So basically if I put index, calculate with 0 and high 8, and it basically return the index. So that is done. So you will remove from the stack. Okay, and you got the index. Now you are calling quick sort function with low and index -1, 4 -1. So what you will do, you will call the same function with the same low and index, that is 4 -1. So you are calling between 0 to 3. So you are calling quick sort function 0 to 3, right? So you are calling quick sort function 0 to 3. Now let's first execute this one. Again, I will come here, is low is less greater than equals to high. So what is low? Low is at 0 and high is at 3. So my low pointer will change, right? Low will be here and my high pointer will be here. Okay. Now once I will execute this condition, I will again find the index by partition function. Okay. Again, partition function will call my pivot element will be this one only, right? And I will find out the partition index, right? I will find out the correct position of 2, and what will the correct position of 2? It will be here, right? So 2 will be here and all the lesser elements will come here and greater elements will come here. So 3 will come here. Okay. And 2 is at the correct position, my pivot. So I will say 2 will be at the correct position. So it will return the index of 2, that is 1. So now basically this function, this partition function return the index of the 2 basically, right? So it will return the index of 1. Okay. So basically you can see my I called partition function, it returned the index and it will return the index 1. Now once it is returning, again I have next quick sort function call with low and index minus 1. So now my index is 1. I will call this function again, quick sort with same low and index minus 1, 1 minus 1, 0. So I will call this quick sort with 0 comma 0. Okay. Now let's execute this function 0 comma 0. Now low and high both are pointing same. Right, you can see 0 comma 0, low and high both are same. So when low is greater than or equals to high, simply return. So what I will do, I will simply return from it. Okay. So when I will return to here because this function called it, right? So I will return from here and my next is index plus 1 high, right? So can I say my work is done of this function? Yes, it is. Okay. And I will call the next function, that is quick sort index plus 1, that is 1 plus 1, 2, 2, 3, right? So I will call this function from 2 to 3. So now you can see my low is here and my high is here. So I will execute this one, right? Quick sort with 2 comma 3. I'll execute this one. Is low is greater than equals to high? No, it's not. I will find out the index, right? So basically it will tell me the index of my pivot element and I will take the pivot element 3, right? So what will the correct position of 3? That will be this one only, right? 2. So I will get then answer of 2. My answer will be 2. So when I am getting an answer here from the partition 2, I will again do one function call, that is quick sort low index minus 1. So again one function quick sort low index minus 1, 2 minus 1, that is 1. So when I call this function quick sort 2, index is pointing to 2 here. Okay. Basically here it will be 2 and 2 minus 1 is 1. So I will say is low is greater than equals to high? Yes, low is greater than equals to high. Simply return. So I will simply return from here. Okay. And I will do the, whenever I will return here and I will do the next function call. So next function call will be index plus 1 and high. So index plus 1, 2 plus 1, 3, 3 comma 3, right? So I will execute 3 comma 3. Which function is done? 2 comma 1 is done, right? So I will execute quick sort 3 comma 3. So when I am executing 3 comma 3, low and high both are equal, right? So this will also return, this will also return. And when I will return, this array is sorted. Yes, so I will return. So 3 comma 3 is done. Now can I say 2 comma 3 is also done? Basically, I have done with the index, I got the index and I have called both the functions. That is also done, right? So I will return from here as well. Okay. So I will return 2 comma 3. And now can I say my 0 comma 3 is also done? It called the left part, that is low index minus 1. Okay. And it called the right part, that is index plus 1 and high. So this is also done. So this will also return. So my 0 comma 3 is also done. Okay. Now where I will come from these things, right? I will come to here. I have cleared the left part. Now I will call the right part, that is index plus 1 and high, right? What was my last index? That was 4. If you can remember, 4. Okay. So what I will do, I will again call quick sort with index plus 1 and high. So I will call 5 to 8. So I will take this part where low is pointing to here and high is pointing to here. Okay. I will remove this. I'm calling this one, right? 5 comma 8. Again, is low is greater than equals to high? No. I will find out the index, right? So I will find out the index of this pivot element 7. What will the correct position of 7? That will be here 6. So it will return the index number 6, right? Once it will return the index number 6, I will call the next quick sort function. So here I have called quick sort function 5 comma 8, and then 5 comma 8 will call the next function low to index minus 1, that is 6 minus 1. Quick sort 5 6 minus 1, that is 5 comma 5. It will call this function. When I will execute this function, low is equals to high, I will return it. So I will simply return from it. So 5 comma 5 is done, right? I have not created in the recognition stack, it is done. Okay. Now I will call the next function call. What is the next function call? That is index plus 1 and high. So quick sort index plus 1 and high. So that is 6 plus 1, 7 and high. So I will call 7 comma 8. So now my low is pointing to here. okay, and high is pointing to here. And like from in the left part, my 7 found its correct position, so my pivot 7 will be here, 6 will be okay. 7 comma 8 you called is low is greater than equals to high. No, you will find out the index. So you will find out the correct position of it, and the correct position of it is 7 only, right? So it will return 7 index as an index. So index will be 7. You will call index minus 1. So I will call quick sort, right? Index minus 1, 7 minus 1, that is 6. Now I will execute this function, right? 7 comma 6 is low is greater than equals to high. Yes, I will simply return. So I will return from it. Okay. Now once this is done, I will call this function index plus 1 and high. What is index plus 1 and high? So that is 7 index plus 1, that is 8 comma 8. I will execute this one. Is low is greater than equals to high? Yes, it is equal. So it will return. So this will also return. So can I say my 7 comma 8 is done? Basically it find out the index, it find out the this function and this function, right? So the index was 7, it called 7 plus 7 minus 1 and 7 plus 1. So yes, that is done. I will return back, right? And can I say my 5 is also done? It called the left part, right part and find out the index. So that is also done. I will simply remove from here stack as well, right? And I will again, now pivot is done. I will move to 0 comma 8, and can I say my quick sort of 0 comma 8 is also done, right? I have first find out the index, then I have first find out the quick sort from index minus 1 this part, and I find out the index plus 1 this part, high part. So that is also done, and I will return it to here, right? And that is done here, and now you can simply basically you can check your array is now sorted without taking any extra space. Okay, the only memory that you have taken, that was recursion stack. Okay, and you can see on each time I was just taking pivot each element. So one I have taken here, this I have taken here. So basically you are considering all the elements as a pivot element. So that's why, right, you can take any element to the pivot element, and your array is now sorted. Okay, so this was all about your quick sort. I hope you got basically how this is working. Okay, the main idea is of your partition function. Basically the only goal is you take the pivot element and your task is to find the correct position of pivot element. And how you can find it? If you are able to find all the elements that are lesser than pivot should be on the left side, all the elements that are greater than your pivot should be on the right side, then you will eventually find the correct position of your pivot element. Okay, so this is all about your quick sort. Okay, now let's quickly discuss the time and space complexity of quick sort. So what will the time complexity of it? Now let's see. So you have how many elements in the starting? That is n elements, right? And from n elements you are doing n by 2, right, left part, and you are doing n by 2 right part. Again you are doing n by 2 left part, again n by 2 right part. So that it will be basically n by 2 of n by 2, it will become n by 4, n by 4. So right, we are doing the same exactly as the merge sort, n part, then again recursion of n by 2, then again n by 4, and it will be n by 8, right? And it will be n by 8. So similarly, time complexity of by simply doing the partition, right? Basically partition, again doing in parts, then doing in parts, that will be log n. Okay, that will be log n. And now each partition, what we are doing, we are simply taking 2 pointers, left pointer and right pointer, and my partition is working, right? So here basically if my partition function works in each part, right, here in n by 2, in n by 4, in n by 8, in all the parts, right, it will also take n times, right? So the total time complexity will be n into log n. Okay, exactly same as our merge sort. Basically why it is same as the merge sort? Because in the merge sort also we were doing dividing and we are simply adding. So basically that's why both the algorithms, right, quick sort and merge sort, known as divide and conquer. Okay, so here we basically divide and add the elements. So divide and conquer. So that's why the time complexity is log n, log n log n for the partition, doing the partition by n by 2 in each time. Okay, and this n for the finding the partition index, right, moving the lesser elements on the left side and moving the greater elements on the right side. So that's why the time complexity is n log n. And now let's talk about the space complexity. So space complexity, we are not taking any extra space. We are using my low and high. The only space complexity that can be come, that will be of your recursion stack, right? So recursion stack. So recursion stack is space complexity will be what will be the length, right? What will be your longest leaf node, right? So if this is function, you are calling this one, then this one, then this one. So how many function calls are in the stack in that time? Okay, that is basically your space complexity. So what it will be? So it will be log n, because basically you are taking these function calls, right? And basically what is your function calls we have taken, right? Number of the function calls, it's log n, right? Number of the function calls here we have checked log n, right? So space complexity, again, that's an average case. Okay, log n on the average case only. Okay, so what will be the worst case here, and what will the space complexity of worst? So in quicksort, okay, you can make this point as a note. In quicksort, the worst case is when the array is already sorted. Okay, so worst case is when array is already sorted. Okay, or sorted in reverse manner. Okay, maybe in reverse it is sorted. Why when the array is already sorted in reverse? Okay, let's see, let's understand this thing. So suppose you have this as an array elements. Okay, and yeah, here. And suppose if we have array that is already sorted. Okay, so let me create the array that is already sorted. So here, let's see. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And if the array is already sorted, okay, you will take this left as a pivot element. And what was the perfect position for pivot element? This position only. So even if you are divide the left part, what will the left part? Nothing. And if you divide in the right part, what will the in the right part? Everything. Right. So what you will do? You will move ahead and then you will take this as a pivot. Again, what is the correct position for pivot? Only here, that is 2 itself. So what you will do, you will divide the left part that is already sorted, right part again the complete array. Again, you will take this as a pivot, right? So in this worst case, you need to take each element as a pivot. You need to take each element as a pivot, right? So this will become your worst case, right? This will basically become your worst case whenever the array is already sorted. And in that case, when we have this worst case, then the space complexity will be not log n, it will be big O of n, and you will get memory limit exceeded. Okay, so we need to take this into consideration, and my time complexity will also be increased. Why? Because why it is big O of n? Because of recursion stack. So now log n will also be not log n. In that case, it will become big O of n, right? So big of n into n. So then the time complexity in the worst case will become big of n square. Okay. So from here you can create one node that, okay, let me create it. So in best case, what will the time complexity? So in best case, the time complexity big O of n log n. Okay. And space complexity will be big O of log n. Okay. And what will the array? Array will be a random array. Okay. Array will be a random array. Same is for average case, right? In average case, there is a random array. It will be n log n. Okay. And space complexity will be big O of log n. Okay. And again, you will take the random array. Now, in worst case, what will happen? Array, if array is already sorted, that is in the worst case, right? Array sorted or sorted in reverse, right? And suppose all elements are same, right? That is also one possible, that all the elements are same, right? So if all elements are same, in these three cases, right? What will the time complexity? The time complexity here big O of n square. What will the space complexity? Space complexity will be big O of n. right? Because you will now consider this will be your recursion stack. There will be n recursion function calls. So it will be big of, again, this is all the recursion stack space, right? So remember, right, this is one of the most asked question in quicksort algorithm, right? What will the best, average case and worst case? Okay. So we have understood completely quicksort. Okay. Now in the next video, I will give you the code implementation of it, how you can implement this quicksort. Whatever we have learned, we are going to implement it. Okay. So in the next video, check out the code implementation.